Storms are dynamic atmospheric events characterized by rapid changes in weather conditions. They form due to the interaction of various atmospheric elements, including temperature, pressure, humidity, and wind. Understanding storms is essential not only for predicting weather patterns but also for preparing and mitigating their impacts. This chapter will explore some of the most common types of storms, providing insight into their formation, characteristics, and effects. Thunderstorms are among the most common and recognizable types of storms. They develop in warm, moist air masses and are characterized by the dramatic and often violent weather phenomena. The key elements of thunderstorms include formation. Thunderstorms form when warm, moist air rises and cools, causing condensation and the formation of cumulonimbus clouds. As the air continues to rise, the cloud can grow into a towering structure, reaching high into the atmosphere. Characteristics. Thunderstorms are marked by thunder and lightning. Thunder is the sound caused by the rapid expansion of air heated by lightning, while lightning is a discharge of electrical energy within the storm cloud or between the cloud and the ground. Thunderstorms can also produce heavy rain, hail, and strong winds. Impacts. Severe thunderstorms can lead to flash floods, damage from hail, and strong winds capable of downing trees and power lines. They can also spawn tornadoes, which can significantly increase the destructive potential. Tropical cyclones, known as hurricanes in the Atlantic and typhoons in the Pacific, are large, organized systems of clouds and thunderstorms that originate over warm ocean waters. They are among the most powerful storms on Earth. Formation. Tropical cyclones form over warm ocean waters where the heat and moisture from the sea fuel the storm. A low-pressure area develops, leading to the formation of a cyclonic circulation as the air rises and cools. As the storm intensifies, it can develop a well-defined center known as the eye. Characteristics. Tropical cyclones are characterized by their intense winds, heavy rain, and storm surges. The eye of the storm is a relatively calm area at the center, surrounded by the eye wall, where the most severe weather occurs. The storm can extend over hundreds of miles and bring widespread flooding and wind damage. Impacts. The impacts of tropical cyclones include storm surges that can inundate coastal areas, heavy rainfall leading to flooding, and strong winds that can cause extensive damage to buildings and infrastructure. Tornadoes are violent, rotating columns of air that extend from a thunderstorm to the ground. They are among the most destructive storm phenomena due to their concentrated and intense wind speeds. Formation. Tornadoes form within severe thunderstorms, particularly supercells, where wind shear, changes in wind speed and direction, can lead to the development of a rotating updraft called a mesocyclone. If conditions are right, this rotation can extend downward to form a tornado. Characteristics. Tornadoes are characterized by their funnel shape and can vary in size and intensity. The enhanced Fujita F scale classifies tornadoes from EF0, weakest, to EF5, strongest, based on the damage they cause. The strongest tornadoes can produce winds exceeding 200 miles per hour. Impacts. The impact of a tornado can be devastating, with the potential to level buildings, uproot trees, and throw debris over large distances. Tornadoes are often accompanied by a distinct, roaring sound and can cause significant destruction in a very short amount of time. Winter and cold weather storms present unique challenges due to their icy and frigid conditions. These storms can disrupt daily life, impact infrastructure, and pose significant risks to safety. This chapter will delve into three key types of winter and cold weather storms: blizzards, ice storms, and dust storms. Blizzards are severe winter storms characterized by their combination of strong winds, low temperatures, and heavy snowfall. They create hazardous conditions that can cripple communities and disrupt travel. Formation. Blizzards develop when a low-pressure system interacts with cold air masses, leading to the development of strong winds and heavy snowfall. For a storm to be classified as a blizzard, it must meet specific criteria: wind speeds of 35 miles per hour or greater, visibility reduced to less than a quarter mile, and these conditions must persist for at least 3 hours. Characteristics. The primary features of blizzards include sustained strong winds that create blowing and drifting snow, leading to whiteout conditions where visibility is minimal. The combination of strong winds and snow can cause dangerous drifts and ice accumulation. Impacts. Blizzards can result in significant snow accumulation, making travel nearly impossible and causing disruptions to emergency services. The cold temperatures and wind chill can lead to frostbite and hypothermia for those exposed to the elements. Power outages due to downed power lines are also common. Ice storms occur when freezing rain accumulates on surfaces, creating a dangerous layer of ice. These storms are particularly hazardous because they can lead to severe damage and hazardous conditions. Formation: ice storms form when a layer of warm air is sandwiched between two layers of cold air. As precipitation falls through the warm layer, it becomes liquid rain. When this rain hits cold surfaces, it freezes, forming a layer of ice. Characteristics: the defining feature of an ice storm is the accumulation of ice on surfaces such as roads, power lines, and trees. Even a small amount of ice can cause significant problems due to its weight and slipperiness. Ice accumulation can reach several inches thick, creating dangerous conditions. Impacts: ice storms can cause extensive damage to power lines and trees, leading to widespread power outages. Roads become treacherous and difficult to navigate, increasing the risk of accidents. The weight of ice can also cause structural damage to buildings and infrastructure. Dust storms, also known as haboobs in some regions, occur when strong winds lift and carry large amounts of dust and sand particles over vast distances. They are most common in arid and semi-arid regions. Formation: dust storms form when strong winds blow across dry, loose soil or sand. These winds can be generated by weather systems such as cold fronts or pressure changes. The wind lifts the dust into the air, creating a dense cloud that can travel for miles. Characteristics: dust storms are characterized by low visibility due to the high concentration of dust particles in the air. They can create a dark, ominous sky and can last from a few minutes to several hours. The dust particles can range in size from fine silt to larger sand grains. Impacts: dust storms can reduce visibility to near zero, making travel dangerous. The dust can damage machinery, electronics, and vehicles, as well as lead to respiratory issues for people and animals. Prolonged dust storms can also impact agriculture by eroding soil and reducing crop yields. Winter and cold weather storms present distinct challenges that require specialized preparation and response strategies. Blizzards, ice storms, and dust storms each bring their own set of hazards and impacts, making it essential to understand and anticipate their effects. In the next chapter, we will explore extreme and rare storms, examining the unique characteristics and the severe weather they can produce. Extreme and rare storms often involve unusual conditions or particularly severe phenomena that make them noteworthy. These storms can be intense, surprising, and sometimes difficult to predict. This chapter will examine three types of extreme and rare storms: cyclone bombs, katabatic winds, and microbursts. Cyclone bombs, also known as explosive cyclones, are intense low-pressure systems that experience rapid deepening and strengthening. They are characterized by their explosive development and the severe weather they can bring. Formation: cyclone bombs form when a low-pressure system intensifies rapidly due to the interaction of cold and warm air masses. This process, known as bombogenesis, occurs when the central pressure of the storm drops significantly in a short period, typically 24 hours or less. This rapid intensification creates a powerful and compact storm system. Characteristics: cyclone bombs are marked by their high wind speeds, heavy precipitation, and drastic temperature changes. They often bring strong winds, heavy rain, and in colder regions, significant snowfall. The rapid pressure drop can lead to dramatic weather shifts, including gale-force winds and severe storms. Impacts: the impacts of cyclone bombs can be extensive, including coastal flooding due to storm surges, significant snowfall, and high winds that can cause damage to buildings, power lines, and infrastructure. The rapid changes in weather can also lead to dangerous travel conditions and disrupt daily life. Katabatic winds are strong, cold winds that descend from elevated regions such as mountains or glaciers. These winds can have a significant impact on the local weather and environment. Formation: katabatic winds occur when cold, dense air accumulates in high-altitude areas and then flows downhill due to gravity. As the air descends, it compresses and warms slightly, but it remains cold and dense compared to the surrounding air. These winds are particularly common in polar and mountainous regions. Characteristics: Katabatic winds are characterized by their cold temperatures and strong gusts. They can vary in intensity, from moderate breezes to extremely strong winds exceeding 50 miles per hour. The winds can cause dramatic temperature drops and rapidly alter local weather conditions. Impacts. The impacts of katabatic winds include significant temperature drops, which can affect both human and animal life. In polar regions, these winds can exacerbate the already harsh conditions, leading to extreme cold and challenging survival conditions. In mountainous areas, they can impact weather patterns and contribute to erosion. Microbursts are localized, intense downdrafts of air that occur within thunderstorms. They are known for their sudden and powerful impact, which can cause severe damage over a small area. Formation. Microbursts form within thunderstorms when a column of cooler, denser air rapidly descends and spreads out upon hitting the ground. This phenomenon can occur in both wet and dry conditions, and is often associated with severe convective storms. Characteristics. Microbursts are characterized by their intense, localized wind damage. The winds can spread out from the point of impact, reaching speeds of up to 100 miles per hour or more. Microbursts can be classified into two types: wet microbursts, which bring heavy rain, and dry microbursts, which occur in dry conditions and can lead to dust storms. Impacts. The impacts of microbursts can be severe, including wind damage to buildings, trees, and power lines. They can also create hazardous conditions for aircraft, particularly during takeoff and landing. The sudden, concentrated wind forces can cause damage similar to that of a tornado but over a smaller area. Extreme and rare storms, such as cyclone bombs, katabatic winds, and microbursts, represent some of the most dramatic and intense weather phenomena. Each type has unique characteristics and impacts that can significantly affect the environment and human activities. Understanding these storms helps in preparing for and responding to their effects, ensuring safety and minimizing damage. In the next chapter, we will explore special storm phenomena, delving into unique weather events and their distinctive features. Special storm phenomena include unique and sometimes less common weather events that have distinctive features and impacts. These phenomena often require specific conditions to occur and can produce unusual or dramatic weather effects. This chapter will cover three special storm phenomena: atmospheric rivers, derecho, and dust devils. Atmospheric rivers are narrow corridors of concentrated moisture in the atmosphere that transport large amounts of water vapor from tropical or subtropical regions to other parts of the world. They play a crucial role in global water cycles and weather patterns. Formation. Atmospheric rivers form when warm, moist air from the tropics is carried by prevailing winds toward higher latitudes. These moisture-laden air streams can stretch for thousands of miles but are typically only a few hundred miles wide. When the air reaches cooler regions, it condenses and can lead to heavy precipitation. Characteristics. The primary feature of atmospheric rivers is their high moisture content, which can lead to substantial rainfall or snowfall when the moisture is released. These rivers can produce intense storms, particularly when they make landfall, leading to significant weather events such as heavy rain, flooding, and even landslides. Impacts. Atmospheric rivers can cause severe flooding in regions where they make landfall, especially if the moisture is concentrated over a short period. The heavy precipitation can overwhelm drainage systems and rivers, leading to widespread flooding. They also contribute to snowpack accumulation in mountainous areas, which can influence water supply and hydrology. Derecho are widespread, long-lived windstorms associated with a line of severe thunderstorms. They are characterized by their ability to produce straight-line wind damage over a large area, as opposed to the more localized damage of tornadoes. Formation. Derecho form when a line of thunderstorms develops in an environment with strong wind shear, changes in wind speed and direction with height, and high instability. The thunderstorms can organize into a system with a well-defined gust front that pushes ahead of the storm, leading to a broad swath of damaging winds. Characteristics. Derecho are distinguished by their straight-line winds, which can extend over hundreds of miles. The winds can reach speeds comparable to those of tornadoes, but they are spread over a much larger area. A derecho's path of destruction can be up to several hundred miles long and can last for several hours. Impacts. The impacts of derecho include widespread damage to trees, power lines, and buildings. They can also cause significant disruptions to transportation and utilities. Due to their long duration and extensive coverage, derecho can affect large populations and infrastructure. Dust devils are small, short-lived whirlwinds that form over dry, dusty surfaces. They are often seen in arid or semi-arid regions and are characterized by their rotating column of air. Formation: dust devils form when localized heating of the ground creates rising air currents that can begin to rotate. As the air rises, it can pick up loose dust and sand, creating a visible vortex. Dust devils typically occur on clear, hot days when the ground surface is significantly warmer than the air above. Characteristics: dust devils are usually less intense than tornadoes and are generally much smaller in scale. They can range in size from a few feet to several hundred feet in height and can last from a few seconds to several minutes. The rotation of a dust devil can create a visible column of dust and debris. Impacts: while dust devils are relatively weak compared to other storm phenomena, they can still cause localized damage by lifting and moving debris. They can also reduce visibility and pose a hazard to vehicles and machinery operating in dusty environments. Special storm phenomena, such as atmospheric rivers, derecho, and dust devils, add complexity and variety to the study of weather and storms. Each phenomenon has its own set of characteristics and impacts, influencing weather patterns and environmental conditions in unique ways. Understanding these phenomena helps in preparing for and managing their effects, ensuring that communities and infrastructure are better equipped to handle their impacts. In the next chapter, we will explore unique and lesser-known storms, delving into less common but intriguing weather events. In addition to the well-known storm types, there are unique and lesser-known storms that offer fascinating insights into the diverse nature of weather phenomena. These storms are often characterized by their unusual conditions or the rarity of their occurrence. This chapter will explore 3 such storms: funnel clouds, vortex streets, and St. Elmo's fire. Funnel clouds are rotating, funnel-shaped clouds that extend from the base of a thunderstorm but do not touch the ground. They are considered a precursor to tornadoes and can develop into tornadoes if they make contact with the surface. Formation: funnel clouds form in severe thunderstorms, particularly supercells, where strong vertical wind shear creates a rotating column of air known as a mesocyclone. If this rotation extends downward, it can develop into a funnel cloud. Funnel clouds are often visible when they pick up moisture or dust, making them more prominent. Characteristics: funnel clouds are typically narrow, tapered clouds that extend downward from the cloud base. They do not cause damage unless they reach the ground to become tornadoes. The rotation of funnel clouds can sometimes be observed visually as they spin in a counterclockwise direction, in the northern hemisphere, or clockwise, in the southern hemisphere. Impacts: funnel clouds themselves do not cause damage unless they develop into tornadoes. However, their presence can serve as a warning of potential tornado development. Observing a funnel cloud can prompt timely warnings and preparedness actions for communities in the path of the storm. Vortex streets are a pattern of alternating rotating vortices that form downwind of an obstacle, such as a mountain or a tall building. These vortices can create interesting and sometimes complex weather patterns. Formation: vortex streets form when wind flows over or around an obstacle, causing the air to separate and create a series of rotating vortices. These vortices align in a regular pattern downwind of the obstacle, resembling a street of swirling air columns. The size and spacing of vortex streets depend on the wind speed, obstacle size, and atmospheric conditions. Characteristics: vortex streets are characterized by their regular arrangement of vortices, which can vary in size and intensity. The vortices can be observed as parallel lines of rotating air or cloud formations, depending on the moisture in the air. The pattern can extend for many miles downwind of the obstacle. Impacts: while vortex streets are generally not hazardous, they can influence local wind patterns and weather conditions. They can create turbulent airflow that might affect aircraft, particularly in mountainous or hilly areas. Vortex streets can also be visually striking and are of interest to meteorologists and atmospheric scientists. St. Elmo's fire is a weather phenomenon characterized by a visible electric discharge that occurs during thunderstorms or in the presence of strong electric fields. It is often seen as a bluish or violet glow around sharp objects such as ship masts, church steeples, or aircraft. Formation: St. Elmo's fire occurs when a strong electric field ionizes the air around a pointed or sharp object, causing a continuous electrical discharge. This discharge is typically weak and does not cause harm but is visible due to the ionization of air molecules, which emits light. The phenomenon is named after Saint Elmo, the patron saint of sailors, as it was often observed by sailors during storms. Characteristics: St. Elmo's fire appears as a bluish or violet glow, often accompanied by a hissing or crackling sound. It can be seen on various objects, such as ship rigging, aircraft wingtips, and church spires. The glow is continuous and can last for several minutes, depending on the strength of the electric field. Impacts: St. Elmo's fire itself does not pose any danger, but its presence can indicate an active electrical field and the potential for lightning. Historically, it has been considered an omen or sign during storms, particularly by sailors and pilots. Modern understanding recognizes it as a visible sign of atmospheric electrical activity. Unique in lesser-known storms, such as funnel clouds, vortex streets, and St. Elmo's fire, illustrate the diverse range of weather phenomena that can occur under specific conditions. Each of these storms provides valuable insights into atmospheric dynamics and can have unique visual and scientific significance. Understanding these phenomena helps broaden our knowledge of weather patterns and contributes to our ability to interpret and respond to various weather events. With this exploration of unique storms, we conclude our comprehensive look at the many forms of storms and their impacts on our world.